Hello, welcome back. We've got a cool episode today, or now. We've already had two other streams today, but for our final trick of the workday, we're gonna make an Essix. So this is something that we're gonna be printing, and then making a suck down after it comes out of the printer. So I'll talk about the workflow as we go through it, but to begin the case, we should identify the problem. So patient shows up with tooth number 12. As you can see, most of it is missing. If we turn it over, it looks like a bomb blew up in it. So this tooth is done. There's nothing else we can do for that. It needs to come out. Problem will be when the patient smiles, you're going to see that he's missing that tooth there, and he is not excited about that. So the ultimate goal will be an implant, but of course implants have to integrate. So while that implant is integrating, he's going to rely on our Essix so that he can smile and be handsome and take lots of pictures for the gram and other places that you may want to look good on. So we begin as always by trimming our model. Let's get rid of all of this noise, things we don't need. We will trim our opposing. Okay. Then we'll set our model axis. Does this really matter for this workflow? Probably not, but I'm so conditioned to doing it, I cannot help myself. All right, we need to go back to edit model. So this tooth being here is not very helpful for us. This doesn't really help us in any significant way. So we're going to use the replace tool. The way this works is we will start by drawing a circle or a line around what is to be replaced. Namely the tooth that is not helpful to us, and then we'll hit apply. It's going to get rid of it. Goodbye. Looks like we've still got some of that in the way. Let's see if we can't use that again before we pull out our other software tricks. Replace, goodbye, that was helpful. Okay, cool. So this is what he looks something like this when I take that tooth out and graft. So let's make this a little bit better by smoothing. And then I'm actually just going to use a remove tool now to just further pull that down. Think of this kind of like a Pontic space. So what we're going to end up doing during this video is we're going to make two models. One of the models is going to be with a tooth digitally waxed onto it. The second model will be this one, which is what I will use to place composite in the tooth and stick it on to cure. So it sounds a little confusing right now as I hear that come out of my mouth, but we'll talk more about it as we go on. So hopefully the workflow will make a little more sense. But all right. So there's our first model. It is simply minus one tooth, right? So we've gotten rid of the broken tooth. That's all fine and dandy. And now we want to create our model. So we will open our model app. It will think for a moment. Waiting on load bars is probably one of the most difficult things I do all day. Turns out I'm not super patient, something I'm working on. In the future, maybe we'll have supercomputers that allow us to not wait as long. All right, so we're in the model app. This is the clean model prompt. So what it's going to do for us is create a model, and it wants to know, like, hey, what parts of this scan do you think are important? So things like this jumbled mess, I just simply don't care about, especially since it's on the bottom. We're not using that anyway. It just takes longer for it to calculate. Let's turn off this upper model so we can see this rat's nest in the back and get rid of this. Again, I just don't need this. I'm not even considering the lower model until I am waxing his tooth. All right, so that looks easier for it to compute. Let's turn the lower jaw off, upper jaw back on. We're gonna do the same thing here, which is where I really don't need his wisdom tooth. So I'm just gonna cut it off. I don't need anything over on this side of the model. I'm gonna stop his Essix. I'll probably end up stopping at around 10, but I'll decide that when I'm doing the lab work. So that all looks okay. Let's click apply. It's going to compute and we get to drink coffee and wait on the load. Thinking wheel of patience spins around and around. There it goes. Okay. So it has created a model for us. Perfect. Let's go to our next screen. We're not going to make any stumps. I tried that workflow before. It didn't work as well. I like this one better. So really, we just go to the end. Ultimately, this model will end up being what we form his, well, one model will be used to create the Essix. So the one we're going to digitally wax here in a minute, I'll make a suck down matrix. It's where we heat a piece of plastic and we pull it down with a vacuum form. So it creates negative pressure and sucks that hot plastic over the cast to create a stent. And then this model that we're computing right now is going to be what I use to when I pack composite into our Essix to be the shape of the tooth. I will put it on this model to cure so that I make sure I've got a little ovate ponic space, which I may ditch out some more in the lab. Also, carve our model out here so we can save some resin. But also it makes sure that I have a cast I can try that Essix on and off to make sure it fits well. Because of course, once I put that composite in that digitally waxed tooth that I'm going to make, it will no longer fit onto the model that has a tooth on it. So we have carved out the model. You can see all of that space is hollow. So it's going to save us on resin, and now we're ready to export our file. So I'm going to turn my screen off so the HIPAA police are happy. Go, so I can name my file. Okay, give me just a moment. And I'll turn my screen back on for you. Okay, so we have successfully saved that. We can turn this off. I will bring you back into view of what we're doing. And now we go back to our administration phase. So for my next trick, we're going to wax a restoration. So we're going to be digitally waxing a tooth now. It doesn't really matter what material I pick because I'm just making a tooth to digitally seat. See that in a moment. We've already trimmed all of our models. We don't need to do that. We've already set our model axis. We don't need to do that. Just going to click through this menu here at the bottom of our screen. All right, so it wants us to draw a margin for which this tooth will exist. It's kind of like it's almost like drawing a baseline for a Pontic. So if you've ever designed a bridge before, there's a screen where we can edit our baseline on the Pontic. That's kind of what this is. All right, search and access doesn't matter. We don't want to make a model. We want to go into design. Okay, minimal thickness, none of this matters because we're not actually making a tooth. We're really just using this positioning tool. So we're going to turn off this adapted restoration calculation, and we literally are just putting a tooth where it's supposed to go. So let's see. What do we want this tooth to look like? We definitely want it to fill that space. And really the algorithm did a pretty good job making that buccal cusp. So we want it to be just a little bit shorter than the cuspid there. We want it to be about the same height as that bicuspid. So that pretty much looks like what I want. I'm going to bring that forward just a little bit. And now I'm happy. So we'll fix that hyperocclusion here in just a minute. Let's get our proposal. Now, because I unchecked that constrained adoption, which I'll go back and show you again here in just a second, it's a little, well, let's see, positioning. Yeah, so this adapted restoration calculation is supposed to just take what I've given it and attach it to the margin. So it looks like it moved it some. That's fine. I can fix this. We'll just use our shape tools. We'll use the shape anatomical, try and save us some time. We're going to make this thing look clinically acceptable. That does not look good. Let's fix that. All right. We'll use our shape circular, almost like we're making the crown. And it doesn't, like, the contour of this doesn't really matter. I really just want it to fill the space that it exists in. So, like, I realize that's an ugly looking proximal contact. It's a digitally waxed tooth that's just getting printed on a model. So that part doesn't really matter. Okay, what does matter is the height of this cusp. And what does matter is how does this look once, if I'm looking at him, how does that tooth look? It's a little bit fat in here, so let's fix that. This might be a good indication for our smooth tool. That will work. That will work. We're going to use shape anatomical to lower this cusp. We want it completely out of occlusion. It's a little shape circular to pull this down some. Yeah, we don't want any occlusion on that tooth. We literally just want it to look nice when he smiles. So we'll go back. Do we love the way this looks? It looks okay. What can we do to make it look nicer? Tuck in this line angle some. help us make that tooth look a little less chunky. It's a little beefy right there to me. So slim that down some. And the beauty of this is it doesn't even really matter what it looks like, because when it comes out of the printer, I can cut it down, I can composite to it. Like I can change the shape of this after I print it. It's just typically easier to do on the computer because I like doing it with the design software. All right, let's add a couple more things here. So I'm gonna on a grid. Yeah, so I'm okay with this, the cuspid being the longest, this bicuspid, first bicuspid being a little bit shorter, and then that second bicuspid being a touch shorter. So he's going to have a nice progression or a nice natural rise in that curve of speed there. So that should look good. When I look at his profile here, I can see that tooth falls about where it's supposed to. So ultimately, this should work for what I need it to do. Is it the most beautiful tooth we've ever done? No. But it is going to be a suck down Essix. It's going to be fine. This will work. This will look like a tooth when it's in his mouth, which is what we're here for. Okay, so we go to finalize. We're going to go back to administration. Now we get our fancy new tool here that says insert all. We could insert selected. They're the same since we just have one restoration. So we don't care about insert geometry. We're not milling this, we're printing. The restoration is seated. Now we go back for our model. So you'll see now when we go to our model phase, we have our digitally waxed tooth that is present on the cast. So we open in lab model once again. We're going to go through the same steps we did earlier so that we can create a cast, this time with that tooth that we've digitally waxed and virtually seated on the model. So again, there it is. So there's our tooth we waxed. Looks like a tooth to me. Let's clean our model. So it's going to give us all of this crazy stuff. Let's fix some of our lines here so that it doesn't take quite as long to compute. Go, that will work fine. And then the lower we don't care about, we're not printing all of it. So I just want it to compute as quickly as possible. As far as this goes, it's fine. So just don't need all of this. Just don't need it. So get rid of that. This I don't care about. And I definitely don't want that wisdom tooth. We're not going to send an Essix to his wisdom tooth to clean on. Just not important. Okay, apply. Wait for the load bar, drink some coffee. Read some Discord messages. There we go. Computed much faster. So same steps as before. We're going to go next. We really don't care about any of these screens other than saving our resin by hollowing out the model. So you can see it's flat right now. All of that's going to be resin or plastic that it prints. We don't need it to be like that. We're just going to carve it out, click apply, and you'll see that part. A lot of this is going to go away. So we'll save some model resin. Save it for another day, another Essix. Okay, there you have it. There's our model. So we're going to export. I'm going to turn my screen off again for the HIPAA police. Turn that off there. I will export this to my same folder that I saved my first file in. This time with tooth. And now we're going to open our CAM software. So I have not had CAM software on stream yet. This will be our first time I'm showing it to you. Let me turn my screen back on so that you can follow. I'm going to import our items. Let's see. To import our items. This part, let's see. I'll pull my screen back up here in just a minute. Okay, so here we are. So really, I just wanted you to see both models together. One of the models we are going to make our suck down matrix on is this one right here. You can see this is our tooth that we virtually waxed and seated on that model. So we'll heat the plastic, pull it down with the vacuum form, make that model there. And then once I have that Essix made, I will cut it and trim it. We'll take it off of this cast. I will then use this cast without a tooth to fill that Essix with composite. I will then stick it onto this cast. I will cure that composite to create that ovate conic space, which I'll probably further enhance after it prints. And then I'll be able to try my Essix on and off before the patient arrives, just to make sure it's comfortable taking it in and pulling it out. And that should work well for them. So we are ready to produce. We will move forward into our printing screen. All of this nesting is done automatically on the build plate, so that's a pretty cool thing that NLab does for you. Is it that much easier to be a digital dentist? A lot of this stuff is just automatic. There we go. Build supports, build some drain channels. None of that is in any critical area, so that should work well. And now towards produce. So it looks like my prime print wants me to check some screens there, so I'll do that. Then we should be ready to go. Okay. Here's our prime print. We will select start production. I'm going home for the day. This will print while I'm gone. When we come in the morning, we'll put it in the post-processing unit to wash and cure the models, and then we'll work on the Essix tomorrow during the daytime. So thanks for watching, and we will see you in the next one.